harder. So I want to try and stay within the framework of what the book is going to ask you. I don't want to go too off topic here. So let me see here. X squared over x squared plus 25. X squared over x squared plus 25. Now let's just make it a little nice for us. Let's do this on the interval 0, 10. So let's try and appreciate what it is that we're doing here. Let's take a step back. I'm giving you a function, right? A rational function in this case. And I'm asking you to imagine that you're only allowed to plug the numbers between 0 and 10 into this, right? Between 0 and 10. And I'm asking you, what's the biggest value that would come out of that function? What's the smallest value? And that's a pretty hard question just without any calculus to answer. You could start guessing and picking things, but I mean, maybe you could see some characteristics of the function itself, but just generally speaking, if I hand you a function, give you an interval and say, hey, what's the biggest and smallest value? That's a tough thing to do. But now we have a method. Is that a continuous function on this closed interval? Yeah, I mean, there's nothing I can plug into this to make it mess up, right? Unless I had a minus here, right? If this was a minus, then what would happen? I couldn't plug in 5 or negative 5, right? And 5 would be in here, so that would be a problem. But because it's a plus, it doesn't matter. So first step, critical numbers, right? So what do we do first to find the critical numbers? Find the derivative, right? We got to figure out when the derivative is 0, where it doesn't exist. Yes?
So if that was a negative and let's say 5 is in the domain,
then I'm not asked. Then you can't use the closed interval method because you don't have a continuous function on a closed interval. So yeah, then you would have to go to the open interval method. All right, here we go. Find the derivative. All right, so let's go through this derivative. All right, this is just a quotient rule, right? Derivative of the top times the bottom in parentheses, right? Minus derivative of bottom is 2x as well, times the top, x squared. X squared plus 25, that quantity squared, right? Okay, and that would be the raw derivative, right? That was a quotient rule. That's the raw derivative. Now I'm going to clean this up, okay? I'm going to clean this up. So I'm going to distribute through. Right there. Gives me 2x cubed plus 50x, right? Minus 2x cubed again. Oh, I'm glad to see that. All over x squared plus 25, that quantity squared. You'll see I was happy to see that minus 2x cubed.
You can see it cancel each other.
Yep, they're gone. That just makes it a little easier to look at, right? So now on top I have 50x over x squared plus 25, that whole quantity squared. Okay, that's my derivative, right? That's my derivative, cleaned up. Now what I would like to do is I'd like to figure out where that's 0. So let's start with that. Where's that derivative equal to 0? Okay, well, take it and set it equal to 0, right? And what did I just tell you about fractions being equal to 0? You only have to worry about the top. So this is just becomes 50x equals 0, right? And that means x is 0, right? Is 0 in our interval? Yes? Okay, you know what? This is fine. We could keep going. Can I change the interval just to make this a little more interesting? Let me just, let's just change this right here to negative 5, okay? Just so that we have a critical number in the interval instead of at one of the endpoints. Everyone got that? Change that to negative 5 to 10. Doesn't change anything about domain. Doesn't change anything we've done. It's just those 2 points we're going to plug in at the end. All right.
So the derivative equals 0 at 0?
Yes, if we plug 0 into the derivative, we get 0. Which means, right? Which means that if we go to 0 on the graph, we should expect to see a flat tangent line. Doesn't mean it's a max or a min, it just means that it's going to be a flat tangent line. Why? Because at 0, the derivative is 0. Right? All right, am I done with the critical numbers? Am I done with step 1? No, what else do I need to figure out? Where it doesn't exist. I'll do that up here. Where does this derivative not exist? All right, we'll take a look at that derivative. 50x over x squared plus 25, that whole quantity squared. Is there any number that you could plug in that would cause a problem? I mean, the worst thing you got to worry about here is division by 0, but there's no way you're ever making that denominator 0, right? Because it's adding 25. When you square something, the absolute worst that could ever be would be 0, right? Otherwise, it's going to be a positive number. You add 25, it's still positive. So there's no way you can get 0 down there, right? So do we have any things to worry about here? No. So no critical numbers from here. So we only have one critical number, right? One critical number. It lived in the domain. So now I can move on to step 2, which is to, what do we do for step 2? Plug our critical number into our function, right? We plug 0 into the function, and that should be really nice, shouldn't it? It's 0, isn't it? We plug 0 into that, we get 0. And that's it. Third step. We plug in the 2 endpoints into the original function. Negative 5 and 10. What happens when we plug in negative 5? Oh, that's going to kind of suck, but we do negative 5 squared over negative 5 squared plus 25. That's 25 over 25 plus 25 is 50. You get a half, right? Y'all got that? 25 plus 25, that's a 50. 25 over 50 is a half. So far, 1/2 is the biggest, right? So far. All right, let's plug in 10. 10 squared on top is 100. Over 100 plus 25 is 125. That reduces to be 4/5. 25 goes into both of those. 4/5. Which is the biggest one? 4/5. Right, this is our max. And our min is, what's our min? 0. So again, taking a step back and appreciating what we're doing here, it didn't take us too long to do that, did it? A couple of minutes? What we were able to say is that if you plug any number between negative 5 and 10, any number you want into this function, I promise you that the biggest value you're ever going to get out is 4/5, and the smallest value you're ever going to get out is 0. That's it. That's all that will ever happen. We could verify this with the graph again. X squared over x squared plus 25. And we're looking between negative 5 and 10. Did I do that? Oh, I didn't put negative 5. I just put 5. I was like, oh shit, that's not right. There we go. There we go.
The denominator is squared.
I squared it. It's squared.
whole thing.
Oh, no, you're thinking of the derivative. I'm graphing the original function.
Yeah, got it.
All right, so there's the original function, right? And we can see that at 0, right? At 0, you have 0 as a y value, so that's our minimum, and our maximum happens here at 10. That's exactly what we got, right? Okay, how are we doing? Let's try and do one more example, then we'll take a break, and then when we come back from our break, I'm going to give you an example to work on your own.
So how come we have to find the max and min like this?
Why? How come we have to?
Well, how do I say are we gonna use these max and mins for something eventually?
Yes, I mean, at some point this will apply to a word problem. All right, so something like, I probably should have given you all like a problem to motivate the whole idea to begin, but I just want to dive right into this. Maybe what I'll do is I'll show you a problem like this after we come back from our break. I'll show you like an application, all right? That sound fair to you? I have one ready to go. All right, so next one that I want to do, I want something harder. All right. How about the function f of x equals x times the square root (9 minus x squared) underneath. And we're going to do this on the interval. Let's go negative 1 to 3.
Do we have to specify if we're doing a closed interval method? Or what do you keep
Do you
running over again?
Well, this is just to keep you, like, I wouldn't give you this, like, I wouldn't say to do this.
You would just give us that?
I would just give you that.
And then
This is
hopefully
just,
God may know.
this is what we're doing for each one. Yeah. This is the way the problem would appear, like this. That's it right there. You would have to know to use a closed interval method. And what's the most obvious thing that tells you to use closed interval method?
The domain?
Yeah, it gave you a closed interval, right? So that kind of tells you you're going to use a closed interval. All right, ready? First step, critical numbers. Okay. Take the derivative, come on. What are we going to use?
Chain rule.
Chain? There's chain in there. There's something kind of that supersedes all that, though.
Oh, there's a F times G. There's a product.
There's product right there. There's a product, right? So you can do derivative first times second plus derivative of the second times first. When you do the derivative of the second one, it's the square root. That's going to be chain rule. So let me run through this. The derivative of the first one is 1 times the second.
9 minus x squared plus 1 over 2.
Now the derivative of the square root of something, which is 1 over 2 square roots of whatever that was.
Times 2x.
Now this is where the chain rule comes in, right? Now the derivative of what was under here, negative 2x, right? Derivative of 9 is 0. Derivative of negative x squared is negative 2x. And then times x to finish off the product rule.
So would it be negative 2x somehow?
It'll be, well, I'm going to cancel the 2's, actually.
So negative x
But
squared.
it, finish, oh, there you are. I heard a voice. Was that you? Okay, it's kind of like, sound like it's coming. Product rule. So derivative of this one, right, times this, plus the derivative of this, which is everything up to here, and then times the first one. So just finishing off product. All right, cleaning up. So, see, we haven't really had to clean up and do anything with this, have we? But it's time, okay? It's time. So square root of 9 minus x squared. All right, over here I'm going to cancel these 2's. This has become x squared, and that's a minus. So I'm going to change this plus to a minus, put the x squared on top, and on the bottom I have the square root of 9 minus x squared. There we go. That's my derivative so far. Yeah, well, it depends on what I want to do with it, right? What am I going to do with this? I'm going to be setting this equal to 0, right? So let's go do that. So set this equal to 0. Setting the derivative equal to 0, here's what happens. I look at it and I say, oh crap, right? This is not a simple equation to solve, right? However, I remember this idea that if I have a fraction equal to 0, I only have to worry about the top, right? Now look, there are many different ways to solve this equation. I'm going to show you the way that I do it, all right? If you have some other way, go for it. I just hope that you're doing it properly. You can make mistakes doing algebra wrong, right? I'm going to try and put both of these together into a single fraction. That way I can use this property. So I'm going to get a common denominator and put those together, which means I'm going to look at this as being over 1. And if I do that, I have to multiply, to have the same denominator, I have to multiply this first term over here by what? I'm going to do root 9 minus x squared on the top and bottom here. That's it. Notice I'm not working with both sides of the equation. Like I'm not trying to clear the fractions. That's just my personal preference. I'm just not even worrying about this, and I'm putting them together. Yes?
Would it also work if I just multiply it
That's,
on the side by that?
that's what I'm saying. There's other algebra you can do. I just hope that you do everything correctly. It should work as long as you don't break any rules of algebra. Like, here's a classic example. Pause this for a second. Here's a classic example. You all right? I may have discussed this with you already. This is what I worry about as a student solving an equation like that. This is what I worry. So yes, can you work on both sides of the equation? Absolutely, right? But you got to make sure you're doing it right. So the big mistake I see students make here is this. Divide both sides by x. And you get what? 4 equals x, right? Is that a solution to that equation? 4? Can I plug 4 in there? Is it true?
Oh, yeah.
Yeah, so this is true, yes? But what solution have you missed? 0. Why did you somehow lose that solution? Because you divided by x, which means you're promising me x can't be 0. So the proper way to do this, anyone want to share the proper way to do it? That was wrong. Subtract 4x on both sides. I'll do it this way. And now do what on the right? Factor x out, GCF. Then you'll get both your solutions. So to answer your question, if you want to start looking at this and multiply both sides by something and do it, that's fine. Just make sure you don't make any mistakes with your algebra. I'm going to choose to not mess with this, put these two together, all right? So what happens here on the left side? Or on that first one with the red? Yeah, those two roots multiply together and the roots go away. And then on the bottom I get the common denominator, right? And then I have minus, then the other one was x squared over root 9 minus x squared. They both have the same denominator, equals 0. And now I can put those together, right? Into one fraction. They have the same denominator. And it'll just be 9 minus x squared minus x squared again, which is 9 minus 2x squared. 9 minus 2x squared. All over the square root of 9 minus x squared equals 0. Now I have a single fraction, right? I have a single fraction, a over b, equals 0. So the only thing I need to worry about now is when is the top 0. So I'm going to take this, and from here I'm going to just say, all right, well this means I just need to ask myself when 9 minus 2x squared equals 0. And that is a little quadratic equation. It can be solved many different ways, right? I'm going to choose to solve it by moving the negative 2x to the other side to make it positive 2x squared. I meant to say 2x squared. Add 2x squared to both sides. Divide both sides by 2. And now what? Well, you want to get rid of a positive 2, right? I moved this one over, which made it positive, and then I'm dividing by positive 2. Plus or minus root. See, now we are initiating a square root on both sides. So when I take square root on left and right, we get plus or minus square root of 9 halves equals x. And yeah, we could go further if you want. We could make that, what, 3 over root 2? Do you want me to do that? You don't have to. We need to make sure that this lives in this interval. There's 2 answers here, right? I need to make sure they're in here. So how are you going to figure that out? Probably just get your calculator. Do 9 divided by 4, right? I mean, sorry. What am I doing? What am I? 9 divided by 2, right, would be, what did you say? 9 divided by 2 would be 4.5. Take the square root of that. Someone do it real quick. Save me having to go dig my calculator out. Someone give me square root of 4.5. 2.121. Oh, yeah, okay. That's approximately what x is, right? Okay, that's what x is approximately. Plus or minus this. Okay, so we have 2 answers here, right? Are they both critical numbers?
Yes. Oh, no, never mind.
Only one of them lives in there, right? Which one of them? The positive. So x is 2.12. Is my only critical number. Does anyone have a question? Yes.
Actually, yes.
Okay.
We rewind a bit. I kind of missed how you got from that fraction to that arrow. Yeah.
This is a fraction, right? A over b equals 0, right?
Oh, right, yeah.
We're good?
Yeah.
Okay.
I forgot that whole, it doesn't matter.
Yeah, this is, I'm using a over b equals 0 really means that a equals 0, right?
Got it.
Okay. Which is why I got a common denominator to begin with, right? When we were earlier in the problem, we had 2 fractions being subtracted equals 0. I had to put them together to use that property. Yes? Yeah, so I only have one critical number so far, right? One critical number so far. Now, what I need to do is figure out where the derivative doesn't exist. May I proceed? All right, so I'm still in step 1. Where does the derivative not exist? Well, I erased my derivative, right? It was up there a while ago. I'm going to go back into my work, and I'm going to go back to where I had the derivative written out real nice when I got it to a single fraction. That one right there. All right, that's the one I'm going to use. So I'm going to say that the derivative is the 9 minus 2x squared over square root of 9 minus x squared. And now I have to ask myself if that ever does not exist. Where would it have a problem? Positive or negative 3, right? If I plug in 3 or negative 3, I'm going to have something bad there, right? Is 3 or negative 3 in here? Positive 3 is in here, right? Now, should we call it a critical number? Yes, but aren't we going to test the endpoints anyway? So, I mean, we can call it a critical number if we want. I'll go ahead and do it. X equals 3. Even though it's an endpoint, I'm going to put it here. It's still a critical number. Any other problems that we could have under there? What if x was bigger than 3? Like 4. What if x was 4? Wouldn't we get a negative under there?
Oh, yeah.
But
Bigger than 3.
that's not going to happen because
Oh, because our endpoints are.
our interval, right? Our interval keeps us from ever having that thing down here have a problem. That okay? So we have two critical numbers and we're ready for step 2. Step 2, I'm going to plug the two critical numbers. Now, when I plug this in, right, when I plug this in, I'm not going to plug the decimal in. I'm going to do this one right here. It was the positive, wasn't it, of this? So I'm going to do f of root 9 over 2. And then I've got to plug in 3 as well, my two critical numbers. And I'm plugging those into the original function. Let's do this into the original function here. If I replace that x with root 9 over 2, I get that. And then times the square root of, now, 9 minus, what happens when I square this square root of 9 over 2? When I square that, it's just 9 over 2. Y'all see what I did there? And I'm going to keep going here. This is root 9 over 2 times root of, okay, when I do 9 minus 9 halves, I can get a common denominator here between these two. That would turn into 18 halves minus 9 halves, wouldn't it? Which is 9 over 2 still, right? So this is 9 halves. And then the two roots go away and you just get 9 halves, which is 4.5, right? The reason I did not use the decimal is because I knew just by looking and experience that when I plugged that in, it was going to turn out to be a nice number. If you would have used the decimal, that's fine. That's okay with me. All right, plugging in 3. What happens when you plug 3 into the original function? You get 3 times root 9 minus 9, right? So that's just 0, that's 0. So far it's looking like a max and a min right there. But we've got one more number to plug in. What? Negative 1. Oh, this is step 3, sorry. The two endpoints, right? See, this is what I'm saying. This was a critical number, or you could look at it as an endpoint, couldn't you? So I don't know where y'all want to put it. It's both, right? So plug in negative 1. You get negative 1 times square root of 9 minus, careful here, negative 1 squared. So 9 plus, well, 9 minus positive 1. So 8. It doesn't turn into a plus because you got to square it first. So this becomes negative root 8. Negative root 8. What's the absolute maximum? That's where absolute max, 9 halves. Absolute minimum. Careful. Negative root 8. Negative root 8 is our minimum because it's a negative number, right? So if I go graph this,
What was the 2.12?
that's the square root of 9 halves, according to.
Oh, we were just trying to figure out.
Yeah, just to get it as a decimal, because we wanted to see if it lived in the interval. Okay, it was x times the square root of 9 minus x squared. And we were looking at this. Check that out. You'll see that graph. We were looking between negative 1 and 3. Right? Between negative 1 and 3. And we found the minimum to be at negative 1 comma negative square root of 8. See that left point popped in right there? And then we found the max to be at, where was it, 4.5? Wait, no. What did we plug in? Square root. Square root of 9 halves. and then comma 9/2. No. There. See that point in green? So again, I hope you can appreciate the fact that, imagine before graphing utilities like this, right? You got people that are trying to optimize, trying to find out these highest and lowest points on a graph. How do you do it, right? How do you do it if you can't just go and type it in and get the points? You have to have some method, right? This is the way we do it. Okay, I think this is a good stopping point, right? And then what I'll do is, when we take our break, I'm going to put a problem up here that you can come back and sit down and just look at, and then we'll talk about it afterward, all right? Let's go till, let's go to 250. I need to check on my family that's still stranded in New York, so. All right, we'll come back, 250.